Hello everyone and welcome to Iland Technology's presentation on basic syslog analysis. Hopefully the information presented here today will help you to monitor and troubleshoot issues you might encounter in your DrayTek device. My name's Darren and I'm the Queensland sales rep at DrayTek Australia and New Zealand. Here we have an outline of what I'll be covering in this session. We'll start by looking at what a syslog is and why we need to use it. Then we'll look at the different ways to view and collect syslogs in DrayTek devices. Finally, we'll look at some scenarios and what to look for in the syslog when troubleshooting a particular issue. If you have any questions during the video, please comment in the chat box on the right side of the screen and stick around at the end for a 5-minute Q&A session. Don't forget you can pause the video or skip back anytime if you'd like a longer look at anything or to hear it again. If you're watching this after the live premiere, please comment below or send an email to sales@draytek.com.au. Let's start by looking at what a syslog is. Syslog is an abbreviation for System Logging Protocol. It's a standard protocol that is used to send system logs or event messages to a specific server called a syslog server. It's primarily used to collect various device logs from several different machines in a central location for monitoring and review. In DrayTek routers, there's different ways to collect the syslog, and the syslog server can be an attached PC, an attached USB flash drive, or local memory in the device. Keep in mind that local memory storage isn't saved, so if the device reboots, the syslogs will be erased. I'll go into more detail on the different methods of collecting syslogs shortly. So why do we need to look at syslogs? Well, on a daily basis, you can view syslogs to check that the router and the network is working normally. This can be to check that firewall rules as well as other security settings are working as expected. For example, you might be blocking access to certain websites and you want to see when attempts are made to access these sites. Other tasks include monitoring internet activity. This can include unusual events such as attempts to gain access to the router from the internet via a VPN or a brute force attack. The most common reason we use syslog is when an issue occurs which cannot be resolved easily. This includes VPN and internet connectivity where connections fail to come up. When a DOS or denial of service event occurs, you can use the syslog to find the source of the event and take appropriate action such as blocking the incoming connection. At DrayTek Support, when we help customers troubleshoot an issue, we almost always ask for the syslogs to help us isolate the cause. If the issue can't be resolved locally, then it's usually forwarded to DrayTek R&D for analysis and a fix if it's related to the firmware not working as expected. There are different types of logs that can be collected, as well as data captures that are used to analyze different issues. I'll cover those a little later. Here's a sample of a syslog from a DrayTek router. As you can see, there are many parts in each log. We have a date and timestamp and matching events. It helps to understand the processes involved to troubleshoot an issue by analysing the syslog. As mentioned, there are a number of parts in a syslog entry. It always includes a timestamp, so it helps if the router is configured to have the correct time and date to help locate the relevant logs when an event occurs. The rest of the syslog entry will vary depending on the type of syslog being recorded. It will usually include an entry for the type of syslog such as VPN, Firewall, or CSM. I'll go over some examples later for you. Another common component is the source or destination IP address, and then we have the message section which provides details of the event. Sometimes a syslog entry can span several lines like the one in the green box here. In addition, the way the syslog is presented will depend on the method the syslogs are collected. Now that we have an idea of what a syslog is, let's take a look at the different ways you can collect syslogs. There's a number of application notes available in our knowledge base showing the different methods that can be used. I'll go over each of these methods now, but I'll also include these links in the description below. The first method is the syslog tool, which runs on a Windows PC. It can be downloaded from our website utilities downloads page as shown here, and I'll include a link to that in the description below as well. Another method that can be used to capture syslog is the Syslog Explorer function built into later model routers. To set this up, go to Diagnostics, Syslog Explorer and enable the Web Syslog. Choose the syslog type and the display mode as shown in the diagram here. Keep in mind that this method will only capture a maximum of 1000 log entries, and all the logs are erased if the router is restarted. But you have the option to download the syslog to a file on your PC for further analysis. To avoid the log files being erased if the router restarts, you can save the logs to an attached USB flash drive. This is selected by clicking on the second tab in the Syslog Explorer menu. You will of course need to connect a USB drive to one of the USB ports on the router. Many people might find this method of saving syslogs more convenient because it doesn't require setting up a dedicated syslog server on a PC like the first method I mentioned. The syslogs can be captured over a long period and new daily log files are created automatically. To retrieve or view the syslogs from a USB drive, go to the USB Application File Explorer menu in the router, then select the syslog folder. You have the option to download the logs to your PC for analysis. Let's check out a video with a little more detail about the methods discussed so far.
There are 3 ways to collect a syslog: using Syslog Explorer, save syslog to USB disk, and using Syslog tool. We will log into the router using the default IP address 192.168.1.1 and the default username and password admin. Go to Diagnostics and Syslog Explorer. Enable Web Syslog and choose Always Record the new event. And the router will start to record the logs. To save syslogs to USB disk, go to System Maintenance and Syslog Mail Alert Setup. Enable Syslog access. Enable USB disk where syslog saved to. Choose syslog messages that you would like to collect and click OK to apply the settings. To verify if the USB disk is detected by the router, go to USB Application and File Explorer. Any computer that has Syslog tool installed can be a Syslog server. Syslog tool can be downloaded from DrayTek website. To collect syslog with Syslog tool, go to System Maintenance, Syslog Mail Alert Setup, enable Syslog access, select Syslog Save to Syslog server, enter server IP address as the IP address of the computer which runs Syslog tool, select syslogs you would like to collect, and click OK to apply your settings. Now we will run the Syslog tool on the computer.
Another method to collect router syslogs is to go to the router CLI. Then using telnet, run the log command. The syntax for this command is shown here, and there's options to view different types of logs such as WAN, firewall, or usage logs. Syslogs are continuously recorded in the background, so you may need to flush the log file if you only want to see the new events. As noted here, the logs are erased when the router is restarted, so using the external storage method shown previously may be better in some cases. Here's a small example of what you see when you view the logs via telnet. VoIP syslogs can also be viewed via telnet. These come in handy when VoIP issues are encountered, such as failing to register to a SIP server, or if calls cannot be made or are dropping out. The telnet command being used here is VoIP debug show message, and below it is the type of log you can expect to see. The last type of log we ask for if the router crashes unexpectedly is the debug log. You can see this one by using the telnet command sysverdbg. This log shows information about the firmware version installed in the router, as well as information related to the crash. In the example shown here, the router is operating normally, so the exception debug log information at the bottom is empty. But if there has been a crash, it creates a firmware exception log indicating which process caused the crash. These details are sent to DrayTek R&D for analysis and fixing the firmware if need be. This log is retained in the router after it is power cycled, but it is overwritten when another crash event occurs. For complex issues, it may be required to capture the console logs in the router. This provides much greater detail than the syslogs and is often required by DrayTek R&D to identify if the issue is caused by a firmware bug. This is available in routers running firmware version 3.8.4 and above. The telnet command to use here is syscon2tel-enable. More details are available in the application note in the link shown here, which I'll also include in the description below. It's called How to Collect Console Log through Telnet Command. Sometimes just collecting syslogs will not be enough to troubleshoot a complex issue. In this case, we usually ask for a Wireshark data capture from the router. We use this to see what is happening to the data packets and how they are being processed. This does require a LAN port mirror function to be enabled. In the diagram here, we've set up LAN port 5 to capture all the data from LAN port 2 and WAN 1. The PC running Wireshark will be connected to LAN port 5. There's an application note which provides more details. I'll include a link below to that as well. Higher end routers such as the Vigor 3900, 3910, 2962 and 2960 have a built-in data capture feature. Once the data is captured, you can download it to your PC and use Wireshark to analyze the data packets. Here I have a sample of a Wireshark capture showing the data flow through the router. This can be sent to DrayTek R&D for further analysis if required. Now that we've seen the different ways to capture syslogs, I'll go through how to interpret the syslogs to help in troubleshooting certain issues. The first one we'll look at is the syslog from a firewall filter. In the example here, you can see a number of parts that are of interest, which are highlighted in different colors. The first one is filter, shown in blue. This means that this syslog entry is for a firewall filter rule. Next we have block, shown in red. This means that the data packet has been discarded. The entry shown in green at S:R equals 2.2 means the action was taken by filter set number 2, rule number 2. The entry ICMP refers to the service type. The IP address shown in red shows the source and destination IP address 192.168.1.11 to 8.8.8.8. The next syslog we'll look at is one for app enforcement. Again, there are a number of parts of interest which are highlighted in different colors. The first one is CSM_AE, shown in blue. This means that this syslog entry is related to app enforcement for CSM. Next we have FTP, shown in red. This means that FTP has been selected in the APPE profile. The entry shown in green at S:R equals 13.1 means the action was taken by the APPE profile selected in filter set number 13, rule number 1, which is the default rule of the firewall. Next we have the URL content filter syslog. The first one shown in blue is CSM_UF. This means that this syslog is related to URL for CSM. Next we have type equals KWG:0 equals 0:1, shown in red. This means that it doesn't match any keyword group, but it matches the keyword object number 1. The entry shown in green, 192.168.1.11:50345 to tw.yahoo.com, means the packet is from 192.168.1.11 going to tw.yahoo.com. Next up is the web content filter syslog. The first one in blue is CSM_WF. This means that this syslog is related to the web content filter in CSM. Next we have the section category equals news, shown in red. This means that the data packet matches the category news in the web content filter profile. Here we have the DNS filter syslog. CSM_DNSF in blue there means that this syslog is related to the DNS filter in CSM. DNS in red on the next line means that the data packet is a DNS query. Let's check out some VPN syslogs, which you'll see when experiencing VPN connection issues. The first one we have here is the message only vigor-xxx but no vigor-xxx. This means that the VPN peer isn't receiving a VPN request. That could be either the sending or receiving router isn't reachable on the internet. You can check the accessibility between the two VPN routers by testing if they can ping each other. Also, make sure the routers are listening for VPN requests by enabling the VPN services in the remote access control setup page as shown here. The next syslog we have here is incoming call failed, no such entry for XXX. This means that a PPTP VPN client is trying to establish a VPN tunnel with username XXX, but the router doesn't have a PPTP VPN profile with that username. Another message you may see is -chap login failed. The usual cause for this message is that the PPTP VPN client is attempting to connect using an incorrect password. Another possibility is that the VPN server has more than one VPN profile with the same username. If it does, just delete one of them. Another one is only ISA-KMP_next_KE, but no ISA-KMP_next_ID. This means the IPsec VPN client is attempting to connect using a mismatched pre-shared key. If the VPN profile has a specified remote VPN IP or peer ID, the pre-shared key is the value of that IKE pre-shared key in that VPN profile. If not, it's using the general pre-shared key set at VPN and remote access, IPsec general setup. Next we have client subnet, bunch of X's, FFFF00 match fail. This means that the local IP and mask set in the client profile doesn't match the remote IP and mask configured in the TCP IP network settings. With more people working from home using IKev2 EAP for VPN connections, it helps to understand the IKev2 EAP creation process and the logs to troubleshoot any issues. I'll quickly go through an example of the creation process and look at corresponding syslog entries. More details are available in the application note at the link shown at the bottom of this slide here, which you'll find in the description below. The first message we see is IKE_SA_init. Here the initiator sends an init packet for negotiating the proposal, nat-t, nat traversal, and the authentication method. The next entry in the syslog is IKev2 dbg, IKE-ESA, ini1_out_r1. Here the responder responds to the proposal, nat-t option, and the authentication method. The next entry in the syslog is IKE_SA_auth. Here the initiator sends the IKev2 auth packet and asks for EAP authentication. We should note that some clients like Windows 10 will send its certificate list out in this step, so the auth12 packet size is large and will be fragmented. The next log entry you'll see is the IKE_SA_auth response. Here the responder sends its local certificate out, including the chain certificate, and asks the client's EAP identity for authentication. Since the certificate size is usually over 2048 bytes, the responder will fragment the packet and send the packets out. Now you should see EAP authentication. Here the initiator responds with its EAP identity and the responder authenticates the ID. If the ID authentication is successful, the responder will ask to use MS-CHAP to continue the EAP authentication. Now you should see EAP authentication from the initiator. Here the initiator responds using MS-CHAP version 2 for the EAP authentication. The server starts authenticating the EAP connection and responds with the authentication result. In the final step of authentication, if EAP authentication is successful, the responder will then assign an IP address to the initiator and establish the IPsec VPN tunnel. More details on how to analyze IPsec VPN logs is available in the application note in the link shown here, which will be in the description below. Okay, so to summarize, today we started by looking at what a syslog is and how syslogs can be useful. We also looked at the different components in a syslog entry and the different methods that are available to collect syslogs. Finally, we looked at some examples of firewall and VPN syslogs and explained the meaning of those logs. That included an example of the process of establishing an IKEv2 VPN tunnel and the syslogs you will see. Okay, that's about it for now, but please stay tuned. Our technical team will be answering questions in the live chat on the right of your screen for the next 5 minutes. For more information about DrayTek products, please check out our website at www.draytek.com.au or send us an email to sales@draytek.com.au or give us a call on 02 9838 8899. Don't forget to like and subscribe below, and if you'd like a notification of new premiere videos we're about to launch or anytime we put up a new video, please give the bell a click too. Thanks and bye for now.